circular motion like before. In the last class, what we discussed? What did we discuss in the last class? We discussed about the horizontal circular motion of this thing. Have you seen the notes which I sent you? Guys, did you see the notes?
Yes, sir.
In the last class, we discussed a lot. So let's start. Now, please write here. Next heading. The concept of centrifugal force. Centripetal force now we understood what exactly is centripetal force. We'll do some more numerical based on this. On that. Centripetal. Concept of centripetal is done. So now let's do concept of centrifugal force. What is the centrifugal force? It is a pseudo force. Do you remember pseudo force which we discussed in the first NLM chapter when we started with the forces and all, right? Now, basically, what is a centrifugal force? It is a pseudo force experienced. It is a pseudo force experienced by an observer which moves in the same circular path along with the body and so basically it is this the pseudo force. It is a pseudo force which is experienced by this observer. Please can you see over here? The observer is also moving in the same path as, for example, if this is your circle, okay? So suppose if this is your object, sorry, this is the circular path. This is the center of the circular path, and this is the object. This object is moving with the velocity v, let's say, and the radius is r. So suppose if there is another observer which is standing along with this object. So can you see when this object is rotating, even the observer which is there is also rotating with the same speed with the same radius. So can you see the observer is moving in the same circular path along with the body in circular motion? Then this observer will be experiencing a centrifugal force. Okay, so we'll see what exactly is this. Okay, please remember it is a pseudo force experienced by an observer. Note, since the observer is in a circular motion, let's start it up. Since the observer is in a circular motion, since the observer is in a circular motion, then he is in uh, in an accelerated frame, that is a non-inertial frame. So whenever it is a non-inertial frame, you will observe this pseudo force. Okay, is this clear, guys? Why did you observe this particular thing, non-inertial frame? Why did this observer experience the force which is called as what is centrifugal? Please note the direction of this force. Direction of centrifugal force is always radially outwards, and the magnitude of centrifugal force mass of the object multiplied by acceleration of the observer. Was this your pseudo force, guys? Every time mass of the object multiplied by the acceleration of the observer. Since the observer was along the same circular path, same everything, so hence if I say the mass of the object is m, then acceleration of observer is v square by r. So can you see over here? Centrifugal force is also m square by. Is this clear? So please remember, when considered in a non-inertial frame, then only centrifugal force will come. Centrifugal force. Yeah. Is this clear, guys? Guys, are you writing along with me now?
Yes, sir.
Can centrifugal force and centrifugal force act along the same object at any given time? Same frame of reference. Will this happen? Yes or no? Will this happen or not?
Yes, sir.
Yes, sir.
This will never happen. Centripetal force and centrifugal force cannot act along the same object at any given time in the same frame of reference, because centripetal force is the name given to the real force from an basically that's it. So can you see, guys, centripetal force is basically the name given to the real force acting on the object. In which direction? In radially inward, right? Radially inward from an observer, which is as observed by an observer, which is either at rest or moving constantly. Basically inertia. Whereas centrifugal force is a pseudo force which acts on an object when seen from the frame of a reference of the object moving in the circular path. Then the observer object itself, who is revolving around the circular path, he observes, or basically in that, whatever another observer which is moving along the same path. So they are one in the same thing, right? So frame of reference is the object which is moving in the circular path. That is basically a non-inertial frame. So can you see, guys? They both cannot act simultaneously, non-inertial frame, because frame का दिक्कत रहेगा. This acts in an inertial frame and this acts in a non-inertial frame, which is both are different. So
The
hence, in the
centrifugal
same frame of reference, they will never act. Okay?
the
Yeah, tell me.
the centrifugal force is radially outwards.
Yes, it is radially outwards.
Okay.
So basically, your centrifugal force generally gets balanced with whatever force is acting radially. Okay? Is this clear? So suppose I have a this thing. We'll talk about the same example. We remember the conical pendulum we just discussed, right? That we discussed in the previous class, I guess. Yes or no? Guys, do you remember this conical pendulum? Radius r, length l. So basically, two forces are acting over here, mg and t. So now, can you see this? This object has an acceleration in this direction, ac, right? AC. This is your ground frame. You balance this as what? You said this thing was theta, so this thing was theta, and you said sir, t cos theta is equals to mg, and your t sine theta was providing the necessary centripetal force. Everyone remembers this? In the last class we discussed this, right? This ground frame is basically the inertial frame. So with respect to the inertial ground frame, or basically with respect to this thing, you will observe this acceleration over here. But now, if I talk in the frame of reference of this object, so if I talk about the frame of reference of the bob, so that implies you are sitting on that bob now. So if you are sitting on the bob was accelerating, so hence now you are in a non-inertial frame. And basically, what forces will be acting now? At any one particular instant, the bob will feel that there is this tension. The bob will feel there is this mg. But will the bob feel any acceleration? Because when we talk about the frame of reference of the bob, now the bob is at rest, right? When we talk about the frame of reference of the bob, then now the bob is at rest. But when you do that, it experiences a force in the outward direction, which is basically your centrifugal. And what will be the centrifugal force? It will be equals to mv square by r. So again, when you do theta over here, so you will say t cos theta is equals to mg. T cos theta, should I divide this t cos theta and t sin theta? Is it fine? You understood? So t sin theta, here t cos theta. Here also t cos theta and t sin theta. Can you see, guys, the difference? Can you see the case difference in both the cases? So here now this t sin theta will be providing the centrifugal force, and which is nothing but mass into what is the acceleration of this box, v square by r, right?
Uh,
So can you see the same equations are formed here as well as here. So what is the only difference? The difference is of the frame. Here you will not observe any centripetal force. Here you will observe this centrifugal force. Here you will not, have any force which is in the radially outward direction. You will just say this T sine theta is providing the necessary centripetal. Whereas here you will say this T sine theta is getting balanced with the centrifugal force. Okay. Shall I write it over here? T sine theta is providing necessary centripetal force, and here you will say T sine theta is getting balanced with the centrifugal. Are you understanding this thing, guys? Can you see there is no not significant difference. It's just a conceptual difference. So whenever you're done writing, okay, till here are you done? Are you done using the differences? Can centripetal force and centrifugal force acts on the same object? Huh?
Yes, sir.
Are you done drawing the free body diagram in both the cases?
Yes, sir. Could you scroll down? Yeah. Sir, down.
We'll talk about the cases of this thing. We'll question on circular motion, but only two more concepts are there. Left in this. One is basically the skidding of an automobile. I think you might remember your teacher teaching you this, right? While turning. So basically, this is the first case one. Smooth, horizontal, smooth horizontal, smooth leveled circular track. Basically, it's a smooth horizontal level track. If I draw the front view and I'll draw the top view. So the front view will look somewhat like this. Can you see, guys? This is the smooth horizontal ground, and this is your leveled road. And do you remember the white lines which is there inside, to separate the road? You remember the white lines which are there in the middle of the road? Let's say this is the one way. Okay. You understood the circular track, guys? Guys, did you understand the circular track?
Yes, sir.
Yes, sir.
The top view as well. Well, let us say there is a car. Let me draw a car for you now. You are just able to see the back. You are just able to see the back of the car. You're not able to see the front of the car. The car is moving in that direction, so the velocity is basically it's moving forward, right? Here, from here, you will see the top of the car, the wheels, the front of hatch, the back of hatch, and the dicky. This is the dicky. This is the headlights, and here there is all. So can you see, guys, the front and the back? The front view and the top view of the car. The car is moving in this direction with this velocity v in a circular track of radius how much? R. Everyone is able to understand the diagram, I think so. Are you able to understand it clearly? Are you able to understand it clearly, guys?
Yes, sir.
Yes, sir.
Okay. So basically, this is the front view, top view, and if I just see the car, the view of the car. What is this happening? If I just see the car, looks like again I'm drawing the front or back, whatever you want. Okay. We are seeing the back of the car, right? Let's take logo to the back side. Now, can anyone tell me what all forces will be acting on this car? I'll draw all the forces in color green so that it will be clear to you. Now, can you see the weight of the car will be acting downwards? The mg will be acting downwards in all the cases. Here, the mg will be acting
Right.
into the plane, right?
Yeah.
And the normal reaction will be acting in the upward direction. The normal reaction will be acting in the upward direction. So the normal reaction acting on it will be in the upward direction. Can you see N and mg will become equal? N and
Yep.
mg will become equal, right? Are yes or no?
Sir.
Since the car is not flying up and since the car is not going down, hence N will be equal to mg. What will be acting towards the radius? Can you see over here? Since the car is having an acceleration, is the what is making the car slide in this? Can you see over here, guys? If you see in frame of reference of the car, tell me this particular thing. Suppose you are sitting in this car, and when you are taking a turn towards left. Suppose you are here sitting over here. When you take a turn towards left, what is your tendency to move? Is your tendency towards right? Is your tendency is to move towards right, or is your tendency is to move towards left? When you
Your
take the
tendency.
turn inside the car, what is the tendency?
No, so the car's tendency will be left, but your tendency will be right.
So basically, even the car, we are moving that car in that direction, right? है ना? So the car has a tendency to go straight, but what is causing it to move in this direction? There is only one force which is making it move in this direction, right? That force will be your friction. So basically, in this case, friction acts in this direction, and this friction provides the necessary centripetal force. Is this clear, guys? Please draw the diagram very carefully. Although इतना ज़्यादा detailing नहीं करना है, you don't want to detail this much. But did you understand everything, guys? How exactly is this thing happening? Please draw it, and whenever you're done drawing, just say.
Cancer.
Okay. In this case, the friction acts. Oh, guys, it is rough leveled circular track. Okay, is this clear, guys? Rough leveled circular track. So it's providing the necessary centripetal force for the circular motion. So basically, F is providing the necessary centripetal force, and F, so by the free body diagram, N should be equals to mg, and friction should be equals to mv square by r. Yes or no? Yes or no, guys? By free body diagram of car, is this the case? Is this the force for balance things, right? Friction is providing the necessary centripetal force, so F is equals to mv square by r, and normal reaction equals to mg. And now for the car to not skid over the road, or basically you can say for the safe turning of the car without sliding, this friction should be less than the limiting friction. Yes or no? Friction should be less than limiting friction. Yes or no? Hello, people. For the safe turning of car, the friction should be less than. Since we don't want it to slide, then that implies the friction should be static in nature. No, friction should be less than the limiting friction. The limiting friction is equals to mu multiplied by n, and this friction is equals to mv square by r. Can you see over here? Uh, mv square should be less than mu. So from here I can write n as mg, and this will be v square by r. M will get cancelled out, and from here v is less than equals to under root of 4. So basically the minimum speed, can you see over here? V should be less than mu r. So sorry, the maximum speed. So V maximum is equal to under root of 4. Please write down it as a note. for safe turning, the speed of car should be less than. Is this clear? Please remember this is the maximum speed which should be there so that the car will not skid. If friction will not be present, if the road will be smooth, in case of leveled road, the car will not be able to take it. So basically, what is responsible for this car to make a turn? The friction is responsible. Hai na? If friction is not present, then what will happen?
So if limiting friction is not present, then it slide into the center.
What?
So limiting friction is not present, the car will go into the center. And again crash.
Your voice is breaking, Ganesh. Limiting friction is what? Hello?
If limiting friction is not there,
Limiting friction is
hello?
not there.
Yeah.
Ah,
If friction is not there, the car will not move like in a circle.
yes, exactly. It will keep on moving straight. It will move in a straight line path. It will not be able to take the turn. Okay? Is this clear, guys? Is this clear?
Yes, sir.
Take the next. So this rough leveled circular track is done. Now the second part is smooth bank the road. So smooth bank the circular track. Let me just grab the image from the internet. Otherwise it will keep me too long to draw. Smooth bank circular road diagram. Copy image. Paste. This is bending of cyclists. But I am just talking about the bank they road. I'm showing you how the bank road actually looks like. Huh? Are you able to see the diagrams, guys? Are you able to see the pictures?
Yes, sir. So can you watch me beyond that?
Sure. So, anyways, guys, are you able to see the banked road in every case? Can you see the there is a little bit. The road is made in a sloped manner, right? Can you see the road is made in a sloped manner over here? Hello, guys. Hello.
Yes, sir.
Are you able to see the road over here? Can you see the road is making certain angle with the horizontal, right? Can you see this angle?
Yes.
So basically, these are your banked roads. Okay. So suppose these banked roads are smooth. If these banked roads are smooth, then let me draw exactly what all forces will be active on. Copy image. Hmm. So basically, guys, whenever suppose, can you see a car over here? Can you see a car of mass m? Well, let us consider. You need to draw these diagrams, not these two, guys. You need to draw these two diagrams. So let us consider, but don't draw the friction over here because it is smooth, no? So don't draw the friction over here. No f cos theta and no f sin theta and no f. Okay. I said don't draw it. Don't draw it. My draw. So let us consider a car of mass m. This is important as your school point of view, so that's why we are writing the whole statement. Let us consider a car of mass m moving on a smooth banked road with angle of inclination. Sir, what will be the diagrams which you will draw in school? You will draw something like this, and make it like, है ना? This angle is theta, and draw the car over here. Just draw a box and draw this. This is your car. Okay. Is this clear, guys? After this, draw this. Let's say this is your angle theta. Your car is like this, and basically the car is moving in a circular path line with a radius how much? Everybody understanding the diagram, right? Are you able to understand the diagram?
Yes, sir.
Can you see the center of the circle? The center of the circle is lying in front here, here it is lying. It's not lying over here. Here it's lying over here. Can you see frustum of a cone? It's somewhat like this frustum. It's not frustum, right? Everyone understand what a frustum of a cone is, right? Right? So basically the car is over here and it is moving in a circular path. So anyways, now what are, let us draw the free body diagram. On drawing the free body diagram, what all forces are acting on this? The forces acting on it will be mg in the downward direction and normal reaction in the upward direction, yes or no? Will these be the two forces acting on it? Will these be the two forces acting on it, guys? Hello? Hello? Guys, will these be the two forces? There is no friction, this is smooth, right? So in this case, if I draw the free body diagram, it will be n in this direction, mg in this direction, and can you see the acceleration of the car will be towards the centripetal? Can you see towards the center? So what will be the frame of reference? The frame of reference will be something like this. Hello. Guys, are you able to hear me? Hello.
Yes, sir.
Yes.
आवाज आ-
आ रही है आवाज? So if this is theta, you remember generally we draw it like this. If this is theta, and this is theta, then this should also be theta, right? Vertically opposite to this angle is basically theta. If you want, you can connect it. This is theta, this is theta, this is theta. So basically, this is your normal reaction making an angle theta with mg. Now what to do? The AC is in this direction. The centripetal acceleration is in this direction, right? So can I write it over here? N cos theta, right? Can I write this thing? N cos theta over here and N sin theta over there. Can I write it like this, guys? So can you see from here, N cos theta is equals to Ng since the car is not moving up or down, and N sin theta is providing the necessary centripetal force. Is this clear, guys? When I divide both of them, please remember, for no skidding, of car, this and this should be cancelled out, and tan theta should be equals to square by RG. And from here, V should be equals to circular smooth bank road. The one and only velocity where car will skid is in the previous case. What was happening, guys? In the previous case, can you see there was a range of safe speeds, right? Guys, do you remember it was the range of safe speeds? The range of safe speed was from what? V should be greater than 0 and it should be less than under root of mu rg. Yes or no? So in the case of friction, you got the what? A range of safe speed. Whereas in the case of smooth thing, there is no friction, so there is only one and only one velocity where the car will not skid. Is this clear? Is this clear, guys? Is case 1 and case 2 clear? Is case 1 and case 2 clear, guys?
Yes, sir. Yes.
Now, have you noted it down, guys? Everyone noted
Yes,
it down?
sir. Yes, sir.
Now, the third case is basically rough banked circular road. So now I have rough banked circular road. That implies there is friction as well as banking. So now it's these cases, right, where there is friction as well as banking as well. So what will be the only difference in the previous case and this case? The only difference between the previous case and this case, Control C, The only difference will be the presence of friction. Okay. So basically now there can be two different cases now. Can you see this car can skid above the up the incline and this car can skid down the incline, right? So case one is the car has a tendency to skid up the incline. That is friction acts downward. So if the in this case friction will act down the incline, that implies suppose if you have the same thing, the same diagram. Guys, note it down till here. Guys, have you noted down till here? No need to draw this diagram again. The only difference will be the presence of friction in the previous case and this case. Right? So case one, so you can start directly. Please draw the FBD again. When you will draw the FBD again, in the first case, the friction will act. What will be the direction of friction? The direction of friction will be down the incline because this car is having a tendency to slip up the incline, right? So this will be the friction. If this will be the friction, this angle will be theta, then I can break friction as well. This will be F cos theta, and now this will be F sin theta. Do you remember the diagram which I had, which I deleted earlier? Right or wrong? So now you will be drawing that. Please draw the free body diagram. Or if you are getting confused in drawing the free body diagram, then just draw the normal. So now I understood what is the only difference in this case and the previous case. Just the presence of this one more force is there. So this angle was theta, that angle was also theta and theta, and then again you divided this N and this friction into the two components. Okay. Now please see over here in this case what will be the equations from? Can you see over here? From here, since the block car is not going up or it's not lying up or it's not going deep down into the incline, hence n cos theta should be equals to mg plus f sine theta. Yes or no? And can I write it over here? N cos theta plus mu बाद में लिखेंगे f so can you see this equation, guys? Right? Everyone can see this equation, right? And similarly, can you see over here n sine theta plus f cos theta is providing the necessary centrifugal force. They both combined. The combined effect of both of them is providing the necessary centrifugal. So can you see over here n sine theta x sine theta? Everyone, is this clear, the two equations? So for the limiting case, when the car is just about to slide out. I'm talking only about the limiting case, है ना? So basically, in place of f, I'll write fl. If I'll write f is equals to fl, then what will happen? Mu, fl will be equal to mu, and in place of f, I'll write mu n, right? So dividing equation 2 by equation 1, will I get like this? Can you see this equation 2 is n sine theta plus f cos theta? So n sine theta plus f की जगह पे fl and fl is equal to mu. So mu n cos theta should be equals to mv square by r. And the second equation is n cos theta minus mu n cos theta is equals to mg. So since I was dividing both the equations, guys, do you remember, since I was dividing both of the equations, will this be the case? Will this be the case, guys? On dividing both of them, m will get cancelled out, n will come common, and then n will get cancelled out. So can you see from here, this will be sine theta plus mu cos theta divided by cos theta minus mu cos theta. Hey sir, this should be sine theta. If you want, you can check. N cos theta minus f sine theta is equals to b square by r. Is this clear, guys? Is this clear? Hello, hello. Is this clear?
Yes, sir.
So can
Yes,
you
sir.
see over here? B will be equals to what? What will be B equals to? Acha, I can write this thing as, can you see if I can divide the whole equation by cos theta? Can I divide the whole equation by cos theta? If I divide the whole equation by cos theta in the numerator as well as in the denominator, will it become sine theta upon cos theta? Tan theta plus mu cos theta divided by cos theta, mu cos theta divided by cos theta will be 1 minus mu sin theta divided by cos theta will be tan. So I can write this thing as, how do you get this thing? Divide by cos theta in numerator as well as denominator. So when you get this, you will get this as well. So from here, if I solve this more, will I get b square will be equals to, or basically b will be equals to under root of rg into tan theta plus mu upon 1 minus mu tan theta. Can I write that like this? Please remember, this will be the maximum. I told you, this is the maximum possible cases. I told you limiting case. This will be the maximum. Next case, I'll do the minimum one. So the maximum possible value of velocity for safe turn of this right up. And sir, the formula is not that complex. Is it complex? Do you remember, guys, tan of a plus b? Everyone remembers tan of a plus b? Guys, do you remember what was tan of a plus b? It was equals to tan a plus tan b, 1 plus tan a tan b, right? 1 minus tan a tan b. So can you see tan a plus, just write mu as tan b, 1 minus tan a tan b. So if in case you feel like, sir, I'm having a difficulty in remembering this, then you can relate it with a little bit with maths. Okay. always remember for safe turn the velocity should be less than v. Is it clear, guys? Is this clear? Will you be able to do case 2? Everyone, will you be able to do case 2? If the
Yes,
car
sir.
has a tendency to skid, down the incline. So now the car will have a tendency to skid down the incline, and the friction will act up the incline. So now if I draw the free body diagram of car, it will be like N acting over here, mg acting over here, and the friction will act. Okay, is this clear, guys? Is this clear, the difference between this case and the previous case? Can you see the difference is only the direction of friction, nothing else. Please remember, this is accelerating in this direction. That implies the frame has to be chosen in this direction only. Although we know by choosing this frame, what will happen? Most of the forces are coming out of the frame. Doesn't matter. Still, one of my frame is in the direction of action. Okay. So this is theta, but this is theta, and this is theta. So I can just remove it. This will become n cos theta. This will become n sin. And this mg will remain mg. So can you see now n cos theta plus f sin theta will be balancing mg. So from here the equation I'll get is n cos theta plus f sin theta is equals to mg. And the second equation I'll get, can you see, for the net force to act inwards, n sin theta should be greater than f cos theta. So n sin theta minus f cos theta. Why did I say minus? So that for the net force to act radially inwards, n sin theta is greater than f cos theta. And this is equal to at least I think when you solve it, again the limiting case, you'll put f is equals to xl, I'm not writing the whole thing again. For limiting case, f is equals to fl, and from here d will be equal to under root of rg tan theta minus mu upon 1 plus mu tan. So basically this is the formula of tan A minus tan B. Okay.
So it's RG.
R is the radius and G is the acceleration to gravity. R is the radius in which radius of the turn.
अच्छा ठीक है सर.
Please remember this is the minimum velocity. So that car doesn't sit down. For a rough banked road, the car will not skid anyway, up or down, both cases, when its velocity is v is less than v maximum and v is greater than v minimum. Basically, the velocity of the car should be greater than under root of rg tan theta plus mu 1 minus mu tan theta, and it should be less than under root of rg tan theta minus mu 1 plus theta. Are you getting my point, guys? The car will not skid when the velocity will lie in this range. Then the car will not skid on a rough or banked road. Is this clear, guys? Is this clear, guys?
Yeah.
Clear, guys. I think it is pretty much clear. Now there is one more part which is called as bending of cyclist. Generally, what happens, cyclists, they take whenever they take a turn, they bend themselves. The cycle bends with the normal, right? Why do they do that? So that they can take a sharp turn, right? So I'm giving that as a homework to you. You need to derive it, or do you want me to derive it? Hello, guys. Do you want me to derive it? Is the concept clear, guys? Any doubt in this? Cyril, Parinita, is it clear?
Yes, sir.
Yes, sir.
Yeah. Now the next concept is basically called as bending of cycles. So suppose, guys, this is the okay. Suppose this is the circular track, and the cyclist bends like this. This is the wheel, okay. So can you see the cyclist has bent like this? This is the cyclist. So you understood, right? Guys, everyone understood? So basically, this is the bending of cyclist. Whenever a cyclist is taking a turn, he bends by a certain angle. He bends by a certain angle. So can you see, if this was the axis of the cycle, then the cyclist bent by an angle theta. Yes or no, guys? Hello? Yes or no? So basically, the cyclist bent by an angle theta. Now the question is, what is the safe speed for the cyclist to bend? So let us consider, this is again your school syllabus part. So let us consider a cyclist and a cycle bicycle system. of mass, capital M. So basically, I am talking the mass of the system is capital M, and let's say this is the center of the mass. So basically, will there be an mg acting in this direction? Will there be an mg acting in this direction? Yes or no? The mg will try to pull this cyclist down. There will be a normal reaction acting in this direction, and there will be a friction acting into the right friction acting towards the center of the cell. So let us consider cyclist a bicycle system of mass and moving on a circular on a rough circular horizon on a rough circular level or horizontal track with a velocity. The free body diagram of the cyclist is as follows. A normal reaction acting in this direction. The mg is acting in this direction, and the friction is acting in this direction. Okay, so n is like this, f is like this, and can you see this angle was theta? And what is the direction of acceleration of this observer? Acceleration of this cyclist, is it in this direction? Please write. Done, guys?
Done, sir.
Yes, sir.
So the FBD of the cyclist is as follows. When you draw the FBD after this, what will you do? You'll choose a frame of reference. So the frame will be like this. Why will the frame be like this? Because can you see one of the direction of the frame, one of the axis of the frame is in the direction of acceleration. Always the centripetal acceleration will be towards the, you see, centripetal acceleration will always be radially inwards. So anyways, I can just break this process. So here this will be your n cos theta, and this will be your n sin theta. Yes or no? Yes or no, guys? So here n cos theta will be equals to mg, and here n sin theta will be equals to okay, n sin theta plus f will be equals to n. Is this clear? So I think now you people are able to obtain the relations, right? Special case, if the road is smooth, if the road is smooth and then this guy wants to take a turn, will he be able to take a turn? Yes, you just do friction zero. So here in that case, n cos theta will be equals to mg and n sin theta will be equals to mv square by r. No friction will be there. Are you getting my point, guys? So here also V is equals to under root of RG. ये final result आ जाएगा. Is this clear, guys? Is this clear, guys? So I think you people can solve the previous case as well. You'll write mu into n and all. You solve it later on. Whatever be the answer, accordingly you solve. Is this clear, guys? Any doubt in bending of cyclist as well? And can you see it's the same thing? You just need to focus on the cases, on the normal reaction, on the forces, direction of forces. That's it. Chaliye. Shall I give you some questions now? Hello, people. The theory part of our circular motion is also over. So now your NNM chapter is officially over, except for the questions. When you are done writing, just tell me. We'll start with the question part.
So this is part of motion in plane.
Yeah, like this is part of circular motion. Newton's laws of motion. Motion in a plane is long over. When we started Newton's laws of motion, then that before that whatever distance was in motion in the plane. Okay.
Yes, sir.
Let's do some questions. Guys, suppose there is a horizontal disk Can you see a horizontal disk, guys? This horizontal disk is free to rotate about this axis. Can you see over here? This is free to rotate about its vertical central axis. Initially, this is at rest. Initially, this disk is at rest. Now, at a distance smaller, there is a coin. Can you see there is a coin over here? At a distance smaller, there is a coin. The coefficient of friction between coin and disk is new. Now the question is, find the angular speed at which the disk should be rotated. So that the coin starts slipping or sliding over the disk. So this is your question, guys. Please solve. You need to find out what should be the value of this omega so that this coin starts slipping. Okay. Try to sit on the coin, guys. Sit on that coin and think. When this coin will be rotated, what all forces will be acting on this coin? Will this coin be experiencing a centrifugal force?
तो पहले उसका weight, then centrifugal, then centripetal, then
Centrifugal, centripetal सब एक साथ लगा देगा क्या? I'm thinking about
And-
which frame? Which frame am I thinking about?
The person on the coin.
Okay, तो फिर यहाँ पे only centrifugal will come. Okay,
हाँ.
I'm telling you to think in the frame of reference of coin. So basically, you need to think in frame of reference of coin. Always remember. Can you see a small circle being formed over there? So when we think in the frame of reference of the coin, how many forces acts on this coin? If I draw the free body diagram, there will be a normal reaction from the disk, and there will be weight of the coin in the downward direction mg, right? Yes or no? Since this coin is in an accelerated frame, hence it will feel a centrifugal force as well. Yes or no? And that centrifugal force will be m into, we always write v square by r. Acha, is the velocity given to us? Do we need to find out the velocity? Guys, do we need to find out the velocity or do we need to find the angular speed? If we want to find the angular speed, then don't write v square by r over here. Write omega square into r. Yes or no? So this is the centrifugal force, and since this centrifugal force will have a tendency to move this coin outward, radially outward, hence to stop it, a friction will be acting in this one. Yes or no? And for this coin to start sliding, for the coin to start sliding. Acha, tell me, if the coin wants to slide, in what direction will it slide? Will it slide radially outward or will it slide radially inward? Tell me, in what direction will it slide if it slides? Radially outward or radially inward? Guys, the question is for you people. Yes, Cyril, please tell me, if the coin wants to slip or slide on the disc, will it slide radially outwards or radially inwards?
The radially outwards.
Radially outwards. Na? So if it is having a tendency to slide outward, the friction is trying to oppose that. That's why it was acting inward, right? This F centrifugal force should be greater than equal to the the limiting force. For the coin to start radially outward, the centrifugal force should be greater than the limiting friction. And what is the centrifugal force? Centrifugal force is m omega square r should be greater than equal to, what is the limiting friction? It is equal to mu into n. And can you see n is equal to mg in this case? So this will be equal to m omega square r is greater than mu mg. M say n will get cancelled and omega would be greater than under root of mu. That implies, can you see over here? It is the omega should be greater than this. So the minimum omega is basically, yes or no? And I think this is what they asked in the question, right? Please write it down. Maybe the next question after this. Done? Hello everyone, I just done this question. Can I give you next? Yes, there everyone is able to see a cylinder, right? Yes, is everyone able to see a cylinder? So now there is a block B which is inside a cylinder, and this block B is moving on the walls of the cylinder. Can you see? The block B is moving on the walls on of the cylinder. A block B is supporting at the vertical surfaces. This block B is rotating at an angular speed omega. On inside the cylinder of radius r. Now the question is find the minimum coefficient of friction between block and cylinder for the block to not fall and move outside. Then please solve. Again, what will you do? You will draw the free body diagram, and who will tell me who will tell me this thing? Yes, Aman, please tell me what all forces are acting on this. What all forces are acting in this case on block B? Hello?
Friction.
Friction. Friction will come later. Apart from friction,
Centrifugal and centripetal forces.
I'm telling you again. Centripetal forces and centrifugal forces, they don't act at the same time. And centrifugal force will act later on. If you think in the frame of reference of the block, then centrifugal forces will start acting. है Centripetal force and
Yes.
centrifugal force will never act at the same time, which you also said and Tanish also said just now. It's a centripetal forces and centrifugal forces. No, they don't act at the same time. Either centripetal forces will be acting or centrifugal forces will be acting. Is this clear?
Yes, sir.
Apart from this, I'm telling you what else. Can you see if the mass of this thing is m? Let's say the mass is m. So what all forces are there? Will there be an
Gravitational force.
gravitational force? This is the first force. There is a contact between the cylinder and this thing.
Normal force.
And direction of normal force.
Sir, perpendicular to the cylinder.
And that is
Right.
towards right. So basically this will be the direction of normal reaction. Now can you see this thing? this object has a tendency to slide down. So what will act? What will act here?
A
The force.
friction
Now, ऐसे
upward.
करके now you will decide the direction of friction. Until unless you don't know what is the driving force, how can you decide friction's direction first? Are you getting my point? So step by step
Yes,
process.
sir.
That is why I taught mg first, then normal reaction, and then the other force. Everything has an order, है ना? अब उसके बाद में.
Yes, sir.
अब now tell me, do you want me to do it in the frame of reference of ground, or do you want me to do it in the frame of reference of the block? Which frame of reference do you want? I'll do both.
Sir, can I please leave?
हाँ, sure, no problem.
Thank you.
In the frame of reference of block, पहले we'll do in the frame of reference of ground. So ground and block B. The ground, the frame say there is mg in the downward direction, there is normal reaction in this direction, and there is friction in the upward direction. Yes or no? So here what will you say? Sir, friction is equals to mg, and n is providing the necessary centripetal force. Both are different things, you know? Don't confuse with them, don't apply them together. N is providing the necessary centripetal force. This is how you'll say n is equals to mr omega square. If you do it in the frame of reference of block B, when you be in the frame of reference of ground, the acceleration will be towards the center, right? But when you will do in the frame of reference of the block, then what will the block say? Will the block ever say I'm in motion? Or will the block say I am always at rest? The block says I'm always at rest. So in this case, there will be a centrifugal force acting on the body. This is your centrifugal. Okay. Is this clear, guys? Are you understanding this particular thing? Everyone, are you understanding this thing?
Yes, sir.
Omega square. This is your centrifugal force. So now, if this is at rest, again, can you see F is equals to mg and n is equals to mr omega square. So it doesn't matter whether you think like this or whether you think like this. Ultimately, our equations are going to be the same. And when the equations are getting same, you can just solve it. For the block will not slide, for the block will not slide. Friction should be less than the limiting friction. And can you see F is equals to mg and FL is equals to mu into n. And can you see n is equals to mr omega square? So mg is less than mu mr omega. M say m cut marega, and here mu will be greater than equal to E upon r. Yes or no? So basically, can you see this is the mu should be greater than this. This is the minimum value. The mu minimum. Answer.
Done writing, sir.
Done writing. Chalo, a question for homework right now. The last question is for homework.
सर इजी वन दे दो ना प्लीज.
It is an easy one. Okay. So can everyone see a table? Basically the surface of a table at least. Okay. So this is a table. On this table, I have a block which can move in a circular motion. Can you see, guys? What I did, I basically have a block of mass m and a string of length m. So what I did, I basically connected them like this, and now I'll throw this block. This thing is smooth, okay? No friction anywhere. So when the block rotates with angular speed omega, then tension in the spring is tension in the spring is the length of spring is half, and angular speed is doubled. Find the new function. Easy question है, जल्दी करो. Here, what is providing the necessary centrifugal force? The tension will be providing the necessary centripetal force. So accordingly do it. Do you want this as a homework or do you want to do this now? And with this thick circular motion is complete. We'll come back to the circular motion after discussing your work power energy chapter. Because work power energy has one small part of circular motion left, which is called as vertical circular. Please do this question. Let me bring the work power energy notes. Yes, people, hello. 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 What is the answer? See, in the first case, guys, what will be the tension in the first case? The normal reaction will be balanced with mg. That we know. Since it is smooth, so there is no friction as well. So now what is the only force which is acting in the radially inward direction? The tension. So basically the tension here is providing the necessary centripetal force. So when tension was there, initial force T naught, what was the length of the string initially? The length of the string was L. So can I write it as M L omega square? Now after this, what happened? They halved the string. They did what? They halved the length of the string. So now the new length becomes how much? L by 2. New the length becomes L by 2, and now this is rotating with an angular speed of omega dash how much? Twice. This is what was given in the question. So now again, what will be the tension in the new case? The new case, the tension T dash will be equals to m into L dash into omega dash square. You didn't change the mass, right? Obviously, you can't change it. So m L by 2 and twice of omega square. So when you do this, this comes to be twice of m L omega square. And that's that. Clear, guys? Done?
Done, sir.
Okay. So with this thing, we are done with our chapter circular motion complete.
So fast?
Circular motion is small only. No? Now this. Array, wait,
Oh
let me first come